Hello everyone and welcome back to another video. We have some functions on the board here and we are required to apply the product rule to find the dy over dx, which is the derivatives of the equations that we have on the board. So number one, y is equal to x squared minus 2 sine of 5x. Then number two, we get dy over dx if y is equal to e raised to negative x cos sine of 2x. Then the last one, we are required to determine the dy over dx if y is equal to x raised to 4 ln of x plus 2. Solution. If you're watching us for the first time, please subscribe to this channel so that the next time we produce the wonderful video just like the one that you want to watch, then you will be notified automatically by YouTube. Let's go back here. So number one, we want to get the dy over dx from the function y is equal to x squared minus 1 sine of 5x. But before we look at this, let's look at something here. I want us to remind ourselves some important things here. If you have y is equal to sine of x, then the derivative of that is just the cos of x. Again, for example, if you have y is equal to sine of 2x, so take note, we have 2x here. So the derivative of that is just 2 cos of 2x. So take note, the 2 is going to be there, cos of 2x. Again, if you have a function y is equal to cosine of x, then we know that the derivative of that is equal to negative sine of x. Again, if we have a function y is equal to cos of 3x, then the derivative of that is simply negative 3 sine of 3x. You see, the negative becomes here sine of that 3x. So the value here, you multiply by that. So that is what you're supposed to know before we go here. So let's apply whatever we have seen there here. Let's start by saying if y is equal to uv, where u and v are the functions of x, then what is now the product rule? Then the dy over dx is equal to u v plus u v prime. So that means that you differentiate the u part, then you multiply by the v. You addition to u take u, then you differentiate v. So this is the product rule that we want to apply. So the equation you must make sure that it is the product of the other one. For example, here x squared minus 1 you multiply by sine of 5x. So let's get it very fast so we can apply that. So let's assign this one to be our u and then this one to be our v. So u to be x squared minus 1. What differentiate? So if you differentiate that, get to x. Then our v is sine of 5x. So what is the v prime? When we differentiate that, we get 5 cos of 5x. Cos of 5x. Cosine of 5x. So after now having this, you just now replace back. So that means our dy over dx, the dy over dx will be, so we take u prime and our u prime is 2x, multiply by v and our v is sine or 5x plus we take u, and our u is x squared minus 1. Then we multiply by v prime, and our v prime is 5 cos of 5x. So that means here, conclude here, dy over dx is simply 2x sine of 5x plus, you can multiply this one out and we get 5 x squared minus 5 cos of 5x. And as very simple as such, you guys, that is our answer. Let's look at number 2. I hope you look at number 2 here. So we require to get if y is equal to e raised to negative x cosine of 2x. So again, if you have a function of y is equal to e raised to x, then if you want to differentiate that, you just differentiate this, which is 1, then you multiply by it. So it's going to be 1 e raised to x. And 1 multiplied by ex, you just get ex. Again, if you have y is a function, y is equal to e raised to 2x, then the y prime is, you just differentiate that, which is 2, then you multiply by whatever is there. And you know, if you differentiate cosine of x, you get the negative sine of x. So let's apply that one here. So let's take our u to be e raised to negative x. What is our u prime? So our u prime, when we differentiate that, we get negative e raised to negative x. Then our v to be cos of 2x. V prime, when we differentiate, what do we get? We get negative 2 sine, negative 2 sine of 2x. Take note of that, negative 2 sine of 2x. So the dy over dx, using the product rule, u v plus u v prime. So can we now replace there? Our u prime is negative e raised to negative x. We multiply by v, and our v is cos of 2x plus u, and u is e raised to negative x, multiplied by v prime, and our v prime to negative x, multiplied by v, and our v here, as you can see, cosine of 2x, added to our u, and our u is e raised to negative x multiplied by v, multiplied by v prime, which is negative 2 sine of 2x. So when we do some simplification here, we have negative e raised to negative x cosine of 2x. Let's take this negative here. So we have negative 2 e raised to negative x sine of 2x. So our dy over dx is equal to, we can see this one is common. We can factorize it out. So it is negative e raised to negative x cosine of 2x. Now since this is a negative and this is a negative, so this one becomes a plus 2 sine of 2x. And that is our dy over dx. Let's look at the last one very fast. And it is dy over dx. That's what we want to determine when y is equal to x raised to 4 ln of x plus 2. But I want us to remind ourselves something here before we go here, that if you have a function y is equal to ln of x, then the derivative of that, you differentiate that value which is x, and you get it to be 1 over that value which is there, x. So the derivative of ln of x is 1 over x. Again, if you have a function y is equal to ln of 2x, then derivative of it, you just differentiate 2x, which is 2, then you put it over the number which is there, and still 1 over x. So let's apply that here. So let's have our u to be x raised to 4. So u prime is, differentiate that. If we differentiate that, we get 4x raised to 3. Remember the power, you subtract 1. Then v to be ln of x plus 2. So the v prime is, apply what we have just learned there. You differentiate that, which is 1 over x plus 2. So the dy over dx, when we use the product rule, u prime v plus u v prime. So let's apply our u prime, and our u prime is 4x raised to 3 multiplied by v, and our v, where is our v? Our v here is ln of x plus 2 plus u multiply by v prime, and our v prime is 1 over x plus 2. So when we simplify, we get dy over dx to be 4x raised to 3 natural log of x plus 2 plus x raised to 4 over x plus 2. As easy as A, B, C. You guys. So if you've learned something, please give this video a thumbs up. Bye bye, and see you in the next video.